Hey, what's going on, guys? And this video, again, is more radicals, but this time it's dividing them. And dividing them is one of the things kids, I don't know, it's easy. They don't necessarily like it, but it's pretty simple, pretty straightforward, as long as you stick with the rules, alright? And the first rule about dividing radicals is that if you're ever taking the square root of a fraction, you can just simplify it to become the square root of the numerator divided by the square root of the denominator. Okay, so it becomes square root of 1 over square root of 4. Then what you want to do is you want to see if you can just take the square root or simplify them individually. So the square root of 1 is nice because that's just 1. Square root of 4 is nice, so that's just 2. And this problem is finished. Because there's no more square roots, we're good to go. Okay. This problem, a little more difficult. Well, kind of. So again, take the square root of a fraction, square root the numerator, square root the denominator. Simplify them separately. Square root of 3, we can't do anything with. But we can take the square root of 9, which simplifies to 3. Okay? Again, this is it. We're done. Because we can't simplify anymore. Guys, the square root of 3 and 3 are not the same number, so do not tell me this answer is just 1. Square root of 3 is very different than the number 3. Okay? So again, this is not the same thing, so we're done. Alright, moving along. Square root of 4 over square root of 3. Let's see what we can simplify. Well, square root of 4 becomes 2. Square root of 3 doesn't become anything. Okay? So, this is where we're going to do a little bit of trouble. If we go back to the last problem, we had square root of 3 over 3, and we were done. Because we couldn't simplify anymore. We don't have to do anything. But, when you have 2 over square root of 3, we have to change this, okay? Because there's a rule in mathematics. You cannot have radicals on the denominator, okay? So what we have to do is we have to rationalize our denominator, which in this case is very, very easy. What you want to do is we need to get rid of this square root. And if you remember from the multiplying radicals video, in order to get rid of, well, actually, not to get rid of, but if you remember from that video, a way that we can multiply radical 3 by something to just get a number is you always want to multiply it by the square root of itself. Okay? So you multiply the denominator by whatever that radical is. Since it's radical 3, multiply it by radical 3. But because we're doing mathematics, anything you do to one, you have to do the other. So whenever you do the denominator, you must do the numerator. Okay? And now we get 2 times square root of 3 is just 2 square root of 3. Square root of 3 times square root of 3 is just 3. Okay? And now we gotta look. Can we simplify this at all? No. We're good to go. Next one. 5 over 3 radical 7. Okay? We can't do anything with the 5 and the 3 because we can't. They just stay the same. But we do have a square root of 7 on the denominator. Again, that's not allowed. So the way you get rid of it is you multiply top and bottom by just the square root of 7. Okay? So now it becomes 5 radical 7, since 5 times radical 7 is 5 radical 7, over 3 times radical 7 times radical 7. Well, radical 7 times radical 7 is just 7, but there's already a 3 down there, so it's now 3 times 7, which simplifies to 5 radical 7 over 21. Can we do anything? Nope. That's it. And again, we're good to go. Okay? The reason why you have to do 3 times 7 is because the 3 and radical 7 are being multiplied here. So when this radical 7 times radical 7 becomes just a 7, you still must multiply it by 3, and 3 times 7 is 21. Okay? Again, I'm just doing a lot of different problems of different variations, but they all follow the same pattern. Simplify your square root, or simplify your fraction. Speaking gibberish. If you have a radical in the denominator, you must rationalize and get rid of it, and then simplify again. So this problem, we have radical 6 over radical 3. Well, radical 6 just is actually even easier. Radical 6 can't change. Since there's a radical in the denominator, we multiply both by radical 3. So it becomes 6 times 3 is 18 over 3. Okay? But, again, we must see if we can simplify. We know that radical 18 becomes the square root of 9 times 2. Okay, since 9 is a perfect square, we can bring it out front. So it becomes, the square root of 9 is 3, so it becomes 3 square root of 2 over 3. Well, 3 divided by 3 is 1. They cancel, and you're just left with the square root of 2. This is a nice problem because a lot of stuff cancels. It's also the most difficult because it's the most steps. First you rationalize. Oops. Then you simplify the square root using your perfect squares. Then again, you keep simplifying until you can't simplify anymore. 3 divided by 3 is 1. You're just left with the square root of 2. Alright, 3 radical 6 divided by 6 radical 2. Alright, let's see if we can simplify anything first, just to make our life easier. Radical 6 we can't, radical 2 we can't. But if we notice, 3 divided by 6 becomes 1/2, and then it's still square root of 6, square root of 2. I'm going to erase this one so we don't get, well, don't get confused. Okay, but now again, since we have a square root in the denominator, we must rationalize, multiply both by square root of 2. So now we get radical 12 over 2 times square root of 2 times square root of 2 becomes 4, because radical 2 is 2. 2 times 2 is 4. Again, we can keep simplifying this down. So we want to see, can we get a perfect square to come out of radical 12? And we can, because we can make it 4 times 3. All right, 4 is the greatest perfect square that goes into 12. We can bring 4 out. So it becomes 2 radical 3 over 4. We're not done yet because 2 divided by 4 is 1/2. So you're left with radical 3 over 2. And that is your final answer. So again, this is the hardest one we've done yet, just because there's so many steps. We simplified a fraction, then we rationalized, then we simplified a square root, then we simplified a fraction, and we were done. Okay, but once you get to here, you can't do anything else, so we're good. All right, and that's actually it. Hopefully you enjoyed dividing radicals. Again, it's not that hard. The first thing you do is see if there's anything you can simplify. If there's not, make sure there's no radical in your denominator. If there is, you have to rationalize it, then keep simplifying. Okay. If you have questions, let me know. Check out the rest of the website. Again, if you're still a little bit tricky on this, just redo this. Just redo the video, because the process isn't going to change, just the numbers will. Hope you have a good one. Hope you enjoyed.